All right, so we just, well, the past days we've learned about different transformations. Realizing you're watching this on a different day, we're recording it on the same day, but still talking about the same unit of transformations. And I had a student give me a definition of transformation, and it's something that undergoes a change. So up to this point, if you've watched all the videos we've made, we've learned about the transformation called translation, and that was the sliding around, right? And now we're going to be looking at, is it here? Oh, I made a good guess. We have our reflections, which is going to be our next transformation. So let's jump right in and talk about reflections. So the first thing, probably just basic English definition of a reflection, is if you're looking in a mirror. You're looking at yourself just at a different viewpoint. So we're going to look at that not based in English world, but we're going to look at it based in geometrical math world with shapes. So to give you a good image, I'm going to look at this here, reflections. So if you notice here, we have a shape, and so just going to point out that Mr. Campbell's colorblind, but I can see color. So we have our first shape here, which is blue, and it's okay if Mr. Campbell doesn't see the colors because we have another indicator of the two types before the shape is transformed. So we have our A, B, and C triangle, and then on the other side we have an A prime, which we know is the new shape, a B prime and C prime. So we take our original shape and we reflect it over an axis. So if you notice this right here, this dotted line here, is where the shape is being reflected over. We have, and so notice that our shapes are going to be reflected over our axes. And so right here you can see if I have this axis. So I'm going to also show you, if I were to look at this original shape here, we can see that A is 1 away from the y-axis, and A prime is also 1 away from the y-axis. But if we move our A over here, our A is now 1, 2, 3 away from the y-axis. So that means our A prime also has to be 1, 2, 3 away from the y-axis. And so I know you're not able to fold whatever device you are in front of you in half, but if you thought about, visualize there was a piece of paper, and if you could fold this, these two shapes would be right on top of each other, and that would be your goal of a proper reflection over the y-axis. So we're going to look at a few examples. So if we have, this is telling us to make a reflection over the x-axis. Over the x-axis. So that's reminding yourself. So in your mind, before I do it, make a x-axis with your right arm. So hopefully you are now sitting at your desk or somewhere with your arm like this, a horizontal x-axis, and I'm going to highlight that in yellow for us. I'm going to highlight our x-axis so it runs horizontal in our coordinate grid. So this x-axis is where we're being told to reflect over, and we have a triangle which has 3 vertices. So a vertice is where 2 lines meet. You may hear that term later. So a vertice is where our 2 lines meet. So these two come up and they form this vertice, which is labeled I. And we have a vertice H and G. So G, H, I. So we need to take each of these points and reflect them over the x-axis. So this I point here is 1 spot away from our x-axis. So to reflect it over, it's going to have to be 1 away from the x-axis just on the other side. If we go with our G, it is also 1 away from our x-axis, so it is going to be 1 away from the x-axis on the other side. So remembering to name them, so this is originally G, but now this is going to become G prime. And over here, it was I over here, but once we reflect it, it gets a new name. And we call this, oh, not H, sorry. This becomes I prime. So we haven't reflected our whole thing yet. We still have one more letter, And this one's further away. We're 1, 2, 3 away from the x-axis. So that means it needs to be 3 away from the x-axis on the other side. So 1, 2, 3. So now this here is our h prime. So when we draw our triangle here, we see that this is where it will look if it's reflected over the x-axis.
But Miss Walton, like, it's like running into each other. Like, how can that be right? Like, it's like it's on top of the other one. That's weird.
Great question, Mr. Campbell. Thank you so much.
You're welcome.
So if you, like, again, I know you can't fold your computer screen in half, but if this were this yellow line, if you were to fold this, if you were to fold these on top of each other, you would know that the h and the h prime would then be on top of each other. And the same with your I and I prime. If we folded it along this yellow line, they would be on top of each other, which would then be a reflection. Do you have a better answer for me, Mr. Campbell?
Oh, no, ma'am. I just want to make sure I understood. What I hear you saying is basically that sometimes when we do reflections, they're just going to run into each other. Sometimes, as long as we do the math right, we'll be okay.
Correct.
Super.
Do the math right. Move them the same space from the original away from the axis, and you will be okay.
Thank you, Miss Walton.
You're welcome. Okay, so there, you're right. It does look a little bit discombobulated. That's a new word for you. Look it up. Discombobulated.
It's a great vernacular.
Okay, so we have another example, except this time we're looking for a reflection across the y-axis. So now, let's go ahead. I'm going to highlight my y-axis. So we have our 3 vertices. So remember, that's where your points meet. So we have V, W, and X. And we're asked to take those points, or this whole entire shape, sorry, and reflect them over the y-axis. So I'm saying reflecting the points because I like to do them point by point because it's hard for me to look at it all at one time. So I just reflect each point one at a time, and then I can redraw my shape at the end. So what I'll do is I'll take my V, and I'm going to reflect it over the y-axis, my yellow line. So if I'm 1 away from my y-axis on the left side, I need to be 1 away from my y-axis on the other side. So now it's no longer V, but now we have V prime. And then the same thing with my W. I am 1, 2, 3 away from my y-axis. So it needs to be 3 away from my y-axis just on the other side. So 1, 2, 3. So this becomes no longer W, but W prime. And our last letter is X. And this is, you can see, yellow line here, 1 away from my y-axis. And in order for it to be the same good reflection, it needs to be 1 away from my y-axis on the other side. So this becomes X prime. And I can then draw my triangle. And you see that, again, thinking, yes, they're crossing over again, but imagine in your head if you were to fold that on your y-axis, these 2 points would be right on top of each other. So, pretty easy to visualize when we have that coordinate plane in front of us and move them across, kind of imagining folding your paper, moving the dots, seeing how far they are away from either the x or the y-axis. But sometimes they give you just coordinate points. And if you had a graph, you could take those coordinate points and you could plot them and then do what you needed to do. But if you didn't have a coordinate point, if you didn't have a graph, I'm going to show you how you would do it based on something called a rule. So with transformations, just like we did in translations, we start with an original coordinate pair, remembering that x comes before y. So we have a coordinate pair x, y. And this arrow, which indicates a transformation, we're taking some original amount and we're transforming it to something new. So we have to do something with the x and the x or the y. And with reflections related to across the y-axis, you're actually going to be changing your x value. So if we have this original n, so in order to make this n prime, we have to switch, we have to change the sign of our x value. So this will become -2, and the y stays the same. So I'm going to show you in a rule form, which would be a -x. So this x is going to change from x to a -x, and then the y will stay the same. And so on each of these coordinate points here, the x is going to change its sign. So I shouldn't say it's negative. This doesn't always indicate a negative x. It's not always, sometimes it'll go from positive to negative, and sometimes it'll go from negative to positive. It's just going to switch. So this negative here in this rule is going to indicate a switch. So this will become -1 because it was originally a 1 to start with, and the y is going to stay the same. And our last one, we have a +3. So again, based on our rule across the y-axis, the 3 is going to change to a -3, and the -2 stays the same. So these now become n prime, m prime, and l prime when they are reflected across the y-axis. All right, and that takes us to our reflections unit.